Thank you. Okay, welcome. Let's jump right into it. What I want to do is talk about the agenda, and then I'm going to do a quick poll of the community that's on the call right now. So we're going to talk about knowledge graphs. I'm assuming that most people on the call right now are already using graphs in some way. What I want to do is try to convince you to maybe take away some of those data warehouse dollars or budget or euros and put them towards knowledge graphs, and that you're going to get great reporting, great data science that you couldn't do in other ways. So we're going to talk about some use cases. We're going to talk about that translation process. How do you take a data model? And I'm assuming all of you have relational databases all through your companies or through your organizations. How do we translate that into a knowledge graph model? And then just some simple tasks to get you going as you start to build it. All right, now is your turn. I want you to put yourself in one of these 4 categories. And in the chat, I want to see if we can get as many chat messages as possible. So tell me which of these 4 roles best describes your work right now. And sorry, I'm going to switch over. I'll share again in just a second. I just want to be able to see your comments. Okay, let's see if we can get as many comments as possible. So we've got some business managers, 1 and 3 people are saying. We've got, let me get back to my content. So that's great. We've got lots of developers. Seems like our developers are dominating in here. And then I'm seeing some analysts, data science, business manager, great. Okay, so we've got a good mix, but it seems like we do have a pretty technical group. So once again, sorry, let me switch that. So here's what we're going to do. Let's start looking at what a knowledge graph is, and then we'll start talking about more of some of the technical details. So with the knowledge graph, the key is that you're integrating data. So you've got relational databases scattered all through the organization. They're all containing processes related to probably one department or one kind of use case, you could call it. So those are great if you want to maintain data integrity, but what they're not good at is creating analysis and queries that go across business processes. So with a knowledge graph, the idea is to bring all of these different elements together into one graph. So like you can see on the left, we've got people, hierarchies, events, documents, resources, processes. The key with processes is that a lot of processes don't just stop in one department or in one relational databases. They're going to go from the sales department to the finance department and then to the fulfillment, supply chain. And so you want to be able to connect all those to do analysis. And that's what the knowledge graph is going to do. Now, what differentiates a knowledge graph from any other graph? That's the integration that you've got to think about. So normally, people think about creating a graph around one specific data set or one specific business process. With a knowledge graph, you're trying to create a graph that blends many processes into one and connects as many interrelated objects as possible. So you've got these nodes. You're trying to create relationships wherever it's possible. Now let's talk about that semantic model. What we're talking about there is that this should use plain language, business language, not technical terms. And so we want to make sure that the way the knowledge graph is set up reflects how your business operates. Now, by doing this, then we've got that LLM possibility in the future. So let's look at an example for supply chain. Now, if you're using a supply chain system like SAP, you may have these modules that are creating silos, disconnected data. And so with a knowledge graph, we're trying to blend it all into one graph. So notice on my left side, I've got vendors. On my right side, I've got customers. And I'm trying to create all the possible connections between those. We've got some internal production. We could create some, inventory stockouts or monitoring how much inventory is on hand or forecasting. So all these processes should be created, linked in one graph. Your goal is to create the biggest scope possible so that any type of question that comes in for your business can be answered through this model. So let's go through. So that's one example. We'll look at some others in a minute. What we could do is from this point is start to create relationships to other processes that may not be directly in the supply chain. So I want you to think about invoices. Those are more related to finance. You know, we're asking for a customer to pay, we're collecting the payment. When we're talking about employees, we may be monitoring their productivity or how utilized they are. So those may be normally in different relational databases, or they may be in different graphs. With the knowledge graph, what we're trying to do is bring them all together, and we can easily extend this model as the requirements expand. So if we've got customer reviews, those are fine. We can put them in, connect them to the customer. We could connect them also to the product that was purchased. So that's the goal. Keep extending this. Integrate data from many different data sources. Integrate lots of different business departments so that you can see those reports that go across. So here's some examples. I bring up healthcare because this is a case where it's difficult often to do analysis. I'm going to talk about episode of care. So I want you to imagine that you break your arm. You don't go in just one time for if you break your arm. You may go in one time to get the x-ray and to get a cast. Then you may have a follow-up visit, and then maybe a third follow-up visit where you're finally taking that cast off and the doctor approves that you're ready to go play tennis again. So with healthcare, we're going to call all that an episode of care. And because of all the different interconnected processes and people and procedures, that becomes difficult to analyze. In a graph, though, we can create the sequential relationships between each of those visits, all the different procedures that occurred. So that's something that's difficult to do if we're just looking at a relational database. With financial fraud, we're talking about patterns. And so we could start to see density, or we could see exceptions or outliers in the nodes. We were just talking about supply chain. What we're trying to do there is bring in right from the very beginning of the process to the very end of the process, all of those elements into one picture. So let's talk about building that graph. I'm going to start with this assumption. And let me get back. Sorry about that. Let's go back with this assumption that you already have lots of relational databases and there's no shortage of those. What you do have a shortage of is ways to connect all of those. So this might be a third normal form database model for e-commerce. What we've tried to do here is separate each of the elements into its own place so that we don't have any data duplication. The discounts are in their own table. Products are in their own table. Product groups could be in their own table. So this is a really simplified data model. I'm not showing cardinalities or constraints, but what I'm trying to just show is what you've done is improve data quality by isolating the data, but it's not making it easy to do analysis. Now think about all the things that are not in this picture, not in this diagram. If we wanted to do any kind of customer service analysis, if we wanted to look at marketing that drove these orders, those may all be in different databases. What we want to do is bring those all together. So one option, let's just look at some of these different types of analysis we could do. One that I'll mention would be that customer lifetime value. That's the LTV there, and I'll let you read the other ones. With customer lifetime value, what we're trying to do is say, how did we acquire that customer in the beginning? How many times have we touched that customer, whether it's for a purchase, a return, a customer review, and then how much money did we make through that customer? What is the frequency of their buying? So those are the types of things that you couldn't answer just within this one data model. You'd have to start integrating data. So when we're trying to do even just an e-commerce analysis, you need more data than you can get just from usually one database for one application. So then that brings us to the next question. Well, why don't we build a data warehouse? So here's what a data warehouse might look like, really simplified if we were doing it for e-commerce. So we would have our deliveries in one fact table, our orders in another fact table. If we're dealing with finance, that would be another fact table. If we're dealing with supply chain, another fact table. So inventory might be somewhere else. What these do are, what this type of model does is creates really good opportunities if you just want to analyze deliveries. So if all we care about is deliveries, we've assembled everything necessary to do that type of analysis. What the data dimensional model doesn't do, though, is help us do that cross-fact analysis very easily. So these are some common problems with the dimensional model. This is the data warehouse. The hierarchies are not handled quite as well. The dimensions, as they change, become awkward. And there's different types of slowly changing dimensions, but each one of them has its disadvantages. And then the main thing is the patterns. So with a graph, we can start to see density, we can see clusters, we can see influencers. With the data warehouse, the only thing we can do is start to calculate frequencies. And then we can't really do that very well when a question is going into deliveries and orders. So how long does it take to go from an order till the delivery's been fulfilled? That takes a little more work than if we're doing something just within that order table. So the data warehouse is great for analyzing one function, but it can be weak for analyzing functions as an ecosystem. That's the emphasis I want to make. Now, I'm assuming a lot of you have data warehouse, and you can probably be really creative and answer some of these questions. But the fact is, it's not really designed for that kind of integrated analysis. So let's go back to our graph model. If we start to create a knowledge graph instead of a data warehouse, we can use some of the same data sources. We'll still use that e-commerce database. We'll still use that finance database, and then maybe our warehouse management or supply chain database. But we're bringing it all together. And so this might be what your data model would look like. Now it's a network. You can start to really see if we had that ad group going out, with a certain budget, what was the volume of orders that brought in? What's the return on investment for those ads? How many vendors were trying to supply products? And when do we need to restock? So those types of things are all integrated into one place because of the knowledge graph format. So this data model helps with all those things that the data warehouse was struggling to do. So let's talk about that first point where our events, and so when you think of a fact table in a data warehouse, think of it as a discrete event. Those fact tables create these silos or these kind of isolated areas for those facts. What we're doing here is we're networking and now it's easier to see exactly which delivery corresponded to which order. And we could start to see those second degree effects, that the delivery was driven by an ad that was driven by a campaign. So now I don't need to tell, maybe some of you work for Neo4j. I don't need to sell you on the idea of graphs. I think all of you are already convinced. What I want to sell you on is that your graphs should have a lot of integrated data from a lot of different systems. Some of you may have graphs that are just from one database, and that's great for pattern recognition, but there's so much more you can do when you try to tie together all of your processes together. All right, so you all know about what graphs can do. So let's talk about how we can get from what you're doing today to what we could do with a knowledge graph. So yes, we love arrows. I'm assuming most of you or all of you have used arrows. That's the Neo4j tool to do data modeling. And the earlier you can start to do data modeling, the more time you spend on that, the less time you'll spend on creating code that you have to throw away. So the goal is spend a lot of time creating a really high quality data model, before you jump in and start writing some Python code or some Cypher code. Make sure that you're feeling really comfortable with the relationships. The business feedback is really important. Make sure that what you're modeling looks and acts and feels like what the business is used to. It shouldn't feel like a foreign environment for them. This should feel comfortable for a user, even if they're not a technical user. And like I said at the end, the relationships are the hard part. So I do teach classes at a university, but I also am a practitioner. So every day I'm working on data models. And we spend a ton of time just talking about what relationships should be called. And it seems like sometimes we go too far overanalyzing what the relationship should be called, but it really gives that intuitive use to the user so that they don't have to come and look up a data dictionary to figure out what these things are. And that's also one of the big advantages over a relational data model is that we've got named relationships. We don't have to try to guess how they fit together. All right, so what you're going to do is identify, based on your business requirements, all of the different data sources that you could bring and integrate into this knowledge graph. So one of the key elements is to find a unique identifier with every record. So that if we're looking at this example, it's easy. We've got a product ID. The second thing that's nice and convenient here is we've got a last updated date. So that makes it convenient to identify what's changed. What do we need to bring into our knowledge graph? Now, many times you'll be dealing with data sets that don't have that. So the first question every time you come to a new data set is, what is it that's a unique identifier? Then you want to figure out those relationships between your entities, what will become your node types. Is it one-to-many, one-to-one, many-to-many? Then we've got our, how are we going to do incremental refreshes? Now, ideally, a knowledge graph would be refreshed at least once a day or more often. And so a lot of companies, like where I'm working right now, we're doing Airflow to try to orchestrate that whole process. So we'll take Cypher code, we'll wrap that with Python, and then wrap that in an Airflow task. All right, so then you're getting into the merge process. So I mentioned those natural identifiers. It's just such a critical step to really understand what identifies that node type. Don't do anything with the node type until you figure out what's the granularity, what's the identifier. Otherwise, what you're going to find is you have duplication and that you're going to have a messy graph. So once you've got those identifiers, those unique constraints are going to help you make sure those are enforced. So one of the things I want you to notice here is that we're always using merges. Don't try to do inserts where you're having to spend a lot of time doing what a merge could do for you. So you find that identifier, and then you turn that into your merge anchor. Okay, next we're going to relationships. That can be part of the same script or it could be separate. The goal here, though, is to find relationships between as many diverse data sets as possible. Neo4j will talk to you about supernodes, so I won't spend the time talking about that. You don't want to have millions of relationships into the node, a certain node, or else your performance will be poor. As you find your graph growing, you're going to have to sometimes come back and revisit your relationships. One of the things I want to talk about quickly, sorry, coming back here, is that I've had a lot of conversations about when should something be a node and when should something be a property. My answer is always, if a property is complex with multiple descriptors, multiple dates, or if a property has relationships of its own, then it needs to be its own node type. On the other hand, if it's just a simple value, even if it's a text value, you can just go ahead and make it a property. But these things will evolve. And so there are many cases where you'll start with something as a property, and then later it turns into a node type of its own. All right, so you've got this knowledge graph put together. Here's what we could start to do is look at, in this example, we've got a state, this is the United States, state of Arizona. We've run some ads, in a variety of groups. You can think of a campaign, ad campaign has, or advertising campaign has groups of ads. Which of those drove the orders that we received from customers in Arizona? We can add those up and find the return on investment. We could then add in the campaign. How much did we spend on the campaign? How much did the customer spend? So we've got the orders would have some additional properties that we could use to get the order amounts. All right, so I think all of you understand that this concept of using Cypher to aggregate data. Now we can start to connect things that wouldn't be easy to do in a data warehouse. And that's the point of this slide is with the data warehouse, you're always going to be focused. It's optimized for analyzing one specific event or one specific business process. The graph is optimized to look at the whole network of events. So you get a query like this where you're taking orders and deliveries, a campaign launches, maybe too many people respond, and then we're getting slow delivery because now our delivery capabilities are overtaxed. So that's the kind of thing where we need to have everything integrated to be able to patch together our orders, deliveries, and campaigns. This data warehouse, it is possible, but it's not going to do it as well or as quickly as you could do it with the knowledge graph. So I'm just checking the time. We've only got a few minutes left, so let me go quickly through this. Make sure that you're using the right tool for the right thing. Now, the first item up here talks about transactional databases or transactional applications. I'm not saying graphs can't support those, but I'm saying you wouldn't do that with a knowledge graph. So a knowledge graph, think of that as a subset of graphs. But the knowledge graph is going to be able to do any type of analysis. They're going to be great for supporting your RAG, that's that retrieval augmented generation model for all LLMs. Okay, so I'm going to wrap up with this. We've got lots of different graphs. A knowledge graph is a specific type where you're integrating data from many different business processes into one network. It's got to follow that business semantic model. And I want you to always start small and build and show value quickly. Don't launch a year-long project and wait for a year to show anything to the users. And the last item is this too specific versus too general. That could be a presentation on its own, and I'd love to hear Neo4j staff talk about that one. But you don't want to go so detailed like the first example, and you don't want to be so broad like the second example. So it's always this balancing act where you're trying to find that right level of detail. All right, great. I hope everyone is still with us. Sorry that we started a little bit late. I'm going to stop sharing. And I know we're running low on time, but thanks for your attention and thanks for the patience since I was a little bit late with technical issues.